Hello everyone. This is the fifth and final video on the searching algorithms. And in this opportunity, what I want to do is a tiny bit of a comparison between the two of them. Now, I have given you that link on the slides, and let's take a look at that very quickly because there is a graphical representation of both of the algorithms in there. So if you scroll down a little bit, you should be able to find this in here. So for example, uh, this is the binary search, and this is you can see the binary searching here, and this is the sequential search, which is also the linear search. Now, in both of the cases, he has some sort of target. I don't know if you can define what the target is in there. Yeah, he's looking for number 37. So you can see that the linear search has to start element by element, going by one by one, until it finally finds 37, which happens to be in position 11 out of 16. In the case of the binary search, have a look at how many cases are happening, how many steps are happening. So it starts in the middle, then it goes to the top, the higher end, then it goes to the middle again, then to the lower end until it finally finds it. It finds the element that we're looking for in 3 steps. The linear search instead takes 11 steps until it finally finds the number that it's looking for. So we can already see that the binary search is a lot more efficient than the linear search. Now, the real problem that we have in here is that for the binary search to be indeed more efficient, that means the collection has to be sorted. If it's not sorted, then the collection is not going to be found. Now, the other thing that we can do is we can just to test this. I just want to do a little bit of coding just to test this and compare them in real time. So I want to print to the console each one of the iterations that are happening in both the linear search and the binary search, just to see exactly what we're getting. So what I'm going to do is, for each iteration of the linear search, I'm just going to add a system that adds a println. And in them, what I'm going to say is something like testing and the number that I'm testing. Yeah, in this case, it would be the array get at position I. Okay, we'll see that. And I'm going to repeat exactly the same thing also in this case. But in this case, instead of getting the array at position I, I'm going to get the array at position mean. So hopefully what we're going to see is how many iterations happen before we finally find the element that we have. Now, to make this comparison completely fair, I'm going to move this sorting, and I'm going to give the array sorted to both of the searches. So before I call the searching, I'm going to sort it before the linear search happened or before the binary search happened. And just a final thing, just to make it a little bit nicer, I'm just going to do another printing of the array after it has been sorted. So let's take a look at this and let's run it, and hopefully the number 98 is going to be there. Okay, this is a very good example. 98 is not there. So let's see what happens. So this is my original array, which is not sorted because it has been dynamically created on the run. Now, this is the same array, but this time the elements have been sorted in an ascending way. Now, a priori, I don't know if the element 98 is in there. So what the linear search is going to do is going to test one of them. And you can say that it's testing 2, then it's testing 4, then it's testing 6, then it's testing 9, and so on. How many testing are happening? Well, it really is testing every element in the collection. And at the end, it's just saying -1 is not there. The binary search, on the other hand, started in the middle, then the middle was 121, and the number that is looking is 98. So it went to the lower end and it got to 60. Now the number he's looking for is 98, so he went in the upper section, 91, then went lower, then we went lower again, and then tested 94, and had to go up, found 99, and at this point he has done as many possibilities as he can, and at this point he can say, I don't need to test this anymore. So a little bit of a homework that you can do, if you have any questions with how the binary search is actually doing this, is that you can print in each one of the iterations uh, what are the limits low, high, and middle. So that would give you a taste of how the algorithm is moving in order to find the number in a particular situation. And of course, you can see in here that when the number is not there, it's really, really handy because the binary search can say very quickly that the element is not there anymore. So that was the last thing that I wanted to do in the final video. I really, really appreciate that you watch it. I hope you enjoy it and you find it useful, and I'll see you in the next one.